Need to pay more attention. That's right. On number 4, the last one I was, or number 5, last one I was working on. Actually, number 4. Last one I was working on, number 4. They didn't want me to actually find a zero. They just wanted me to either use synthetic division or the remainder theorem to evaluate p of negative 2, which we got right here going on. So this is our synthetic division for p of negative 2. And we would have gotten right here. I didn't finish it out, but if we would have done it, we would have gotten 28. So p of negative 2 is 28. Now you could have just taken negative 2 and plugged it in and done the math that way in your calculator. That would work as well. Or again, you can use synthetic division and you're going to look for that remainder. Whatever that remainder is, that is what p of negative 2 is. So 5 says use the factor theorem to find a factor of the polynomial. Well, let's continue on, see if they give us one. If they don't, we'll figure it out. 1 says construct a polynomial given the zeros. Okay, so 5 we'll have to come back to later. But 6 says construct a polynomial with the given zeros and their multiplicities. So, has a degree of 5, so I know I'm looking for 5. Count them. 1, 2, 3, 4, 5. Looking for 5 zeros. And I have a 0 at 3, 1 at 2i, and 1 at negative 2 at the multiplicity of 2. Once you see the I, you should say, hey, wait a minute, if there's 1, there's got to be 2. Because there's 2 imaginaries, because of that quadratic formula with the plus and the minus. If there's 1i, there's got to be 2. If there's 1 square root, there's got to be 2. So I have 5 zeros, 5 hippo cheeks, 1, 2, 3, 4, 5. I start out with x minus every time. And then I just have to take and plug the zeros in. So I'm going to take 3 and plug it in. I'm going to take 2i and plug it in. I'm going to take negative 2i and plug that in. And you can see that's going to turn to a plus. Then I take negative 2 and I plug it in twice because that's what that multiplicity of 2 says. So this is what I have. Now, always multiply the ones that have opposites first because things will cancel. So x times x squared plus 2ix, don't think too much about that, minus 2ix, because there it goes, it cancels, minus 4i squared, and I squared is negative 1, so a negative 1 times a negative 4 is a positive 4, so that's x squared plus 4 times x minus 3. We can multiply this guy out. X times x is x squared plus 2x plus 2x plus 4, which is really going to be x squared plus 4x plus 4. You multiply this guy out. X squared times x cubed, x times 4, 4x, negative 3 times x squared, negative 3x squared, negative 3 times 4, sorry about that, negative 12, which then really in standard form looks like this, x cubed minus 3x squared plus 4x minus 12. Then we're going to multiply that times the x squared plus 4x plus 4. Don't get scared of these guys. They're not hard. You just got to follow through, okay? Don't get scared. X cubed times x squared, x to the 5th. X cubed times 4x, 4x to the 4th. X cubed times 4, 4x cubed. Now the negative 3x squared times x squared. It's negative 3x to the 4th. Negative 3x squared times 4x. It's negative 12x cubed. Negative 3x squared times 4 is negative 12x squared. Now the negative 4x. 4x times x squared, 4x cubed. 4x times 4x, 16x squared. 4x times 4, 16x. Now, negative 12 times x squared, negative 12x squared. Negative 12 times 4x, negative 48x. and negative 12 times 4, negative 48. Combining like terms will be x to the 5th plus x to the 4th minus 4x cubed. Let's see, it's going to be a minus 8x squared minus 32x minus 48. And transfer it to 48. That's minus 48. Came from right there. Minus 48 at the end. Okay? Oh, there it is. Minus 48. Okay. Find a polynomial with the given conditions. Degree of 3, 0 is negative 2, 0, and 3. So there's degree of 3 tells us there's 3 hypocheeks. X minus, x minus, x minus. Plug them in. Negative 2, 0, minus 3. Personal opinion, I'd actually multiply these two right here first. But you can multiply these two first. It's fine. It's fine. You don't need to multiply through by the 0. It's not going to do anything. Just the x here. That'll give us x squared plus 2x. You could do the 0, but it's just going to give you 0 and 0, which is just x squared plus 2x. Multiply that by x minus 3. X squared times x is x cubed. X squared times negative 3, negative 3x squared. 2x times x, positive 2x squared. 2x times negative 3, negative 6x. So I get x cubed minus x squared minus 6x. And you're done. So degree of 3, so looking at 3 hypocheeks. 0's of 0. Multiplicity of 2, which means there's 2 of them. 1 at 1. So x times x is x squared. 0's times everything else just can be 0. X squared times x minus 1. I keep forgetting to scoot that up. Sorry, guys. X cubed minus x squared. Done. Find the polynomial with the given conditions. Degree of 2. So there's going to be 2 hypocheeks. 0 is a negative 3, which is plus 3, and negative 1, which is negative 1. Leading coefficient of negative 3. Negative 3 right there. So I get x times x, x squared, plus x, plus 3x, plus 3, which is x squared plus 4x plus 3. And then don't forget your negative 3 leading coefficient, so distribute him in now. Negative 3x squared minus 12x minus 9. All right, turn the page. Use the rational root theorem, Descartes' rule of signs, upper lower bounds theorem to find zeros. Okay, show that 4 is an upper bound. To determine upper bound, you plug it in, and what needs to happen is you need to see that they all are positive. So that's how we determine an upper bound. So here we go. Here we go, here we go. If I plug in 4, so actually, sorry, upper bound. Don't plug it in. Do synthetic division and show that they're all positive. Now notice that I did put a 0 here because it's missing the x. So x cubed, x squared, no x, and then x to the 0, which is this. So drop the 1. 1 times 4 is 4. Add. Giving us 3 times 4 is 12. Add. 12 times 4 is 48. Add. Notice how they're all positive. That shows that 4 is an upper bound. So do synthetic division. Show that they all come out positive. That's an upper bound. Show that negative 4 is a lower bound. What you're going to do is you're going to do, again, synthetic division. But now they should alternate. Positive, negative, positive, negative. So drop the 1. 1 times negative 4, negative 4. Negative 5 times negative 4, 20. Add 20. 20 times negative 4, negative 80. That's going to be negative 76. Notice how they go positive, negative, positive, negative. Therefore, it is a lower bound. Okay? That's upper bound, lower bound. Synthetic division. Again, synthetic division. Upper bound says they're all going to be positive once synthetic division is done. Lower bound, synthetic division. Then they're going to alternate positive, negative, positive, negative. Okay. For the following, use the rational root zero theorem to determine all possible zeros. Use Descartes' rule of signs to determine the number of positive and negatives. Factor it and then sketch the graph. Okay. Would love for this thing to factor completely at the beginning, but it doesn't. So I have to take factors of 10, plus or minus 1, 2, 5, and 10, over 6, factors of 6, 1, 2, and 3. These are all possibles. I'm going to try all the non-fraction ones first, like 1 divided by 1 and negative 1 divided by 1, 2 divided by 1, negative 2 divided by 1, 5 divided by 1, negative 5 divided by 1, 10 divided by 1, negative 10 divided by 1. So in other words, I'm going to try all these guys first. Then I'll go to 1 half, 2 over 2, which is 1, 5 halves, 10 over 2, which is 5. So really just 5 halves and 1 half. And then 1/3, 2/3, 5/3, and 10/3, and the negatives. Hopefully we'll find one in here versus all that stuff. So I can either do synthetic division, 6, 17, 1, negative 10, 6, 6, 23, 23, 24, 24, 14. That's not a 0, so 1 is not in it to win it. Negative 1, 6, 17, 1, negative 10, 6, negative 6. 17 plus negative 6 is 11 times negative 1, negative 11. Negative 10 times negative 1, 10. That's hey. There it is. So it's 6x squared plus 11x minus 10. I would then from here try and factor this thing. 6x squared minus 10, negative 60x squared. Factors of negative 60x squared, they're going to add up to a positive 11. So not negative 1 and 60, not negative 2 and 30, not negative 3 and 20. Oh, but it is negative 4 and 15, negative 4x and 5x. GCF left and up. So GCF left between these two is 2x. Between these two is 5, and that's a plus, so 2x plus 5 is one of the other factors. GCF up here, I'm going to get x. In between these two, 2 and a minus. So x minus 2 is the other factor. So therefore I get zeros here at x equals negative 5 halves. Here I get x equals 0 at 2. So negative 1 was another 0, which must have came from the factor then. Sorry, keep forgetting to slide that down. Okay, so look, x minus 2, 2x plus 5. Then I just take each of these, set them equal to 0, and solve. That gives us our other zeros. X negative 1, that's the 0 from right up here, which then came from a factor of x plus 1. So there it is in factored form. There's the zeros. Now we just need to use Descartes' rule of signs to determine the number of positive and negatives. So Descartes' rule of signs says, take a look at your original. See how many sign changes there are. So positive to positive, none. Positive to positive, none. Positive to negative, 1. That means there's going to be 1 positive 0, real 0. Okay, 1 positive, real 0. If I went, and then you normally go down by 2, but 1 minus 2 is a negative 1, so that doesn't make any sense to have a negative 1 positive 0. So there's just 1 positive 0. Now we're going to put a negative in here and see how the signs change. So that would give me a negative 6. Negative squared is a positive 17. Negative times a positive is a negative. Then negative. So from here to here is 1. Positive to negative is 2. Negative to negative is not, so it's just 2. So there are 2 negatives, and then going down by 2, or 0 negatives. So you either have 2 or 0. And as you can see, we actually have 2 and 1 positive 1. Okay? And, oh, sketch the graph. Oh, sorry about that. Sketch the graph. We know the zeros are a negative 1. negative 5 halves, which is negative 2.5, and 2. We know the end behavior is an odd positive, so that means the end behavior is going like this, opposite directions. Each of these zeros only happens once. They go through, and through. I could find the y-intercept. It's negative 10. So that right there is negative 10. Now we're done. Okay. For each of the following, use the rational root theorem, rational zero theorem to determine all possible rational zeros. So I'm going to look at factors of 12, plus or minus 1, plus or minus 2, 3, 4, 6, and 12, all over plus or minus 1 and plus or minus 2, because of that 2 right there. So all of these are possibles. And then I have to divide by 2, so plus or minus a half. 2 over 2 is 1, I already have it. 3 halves. 4 over 2 is 2, I already have it. 6 over 2 is 3, I already have it. 12 over 2 is 6, I already have it. Those are all possibles. Now it says use Descartes rules of signs to determine the number of positive and negative zeros. So again, I'm looking at sign changes. Positive to negative, there's 1. Negative to negative doesn't change. Negative to a positive, there's a second. Positive, positive doesn't change. Positive to negative, there's a third. Negative, positive, there's a fourth. So for positives, there could either be 4 or 2 or 0, because you go down by 2's. 4, 2, or 0. For negatives, we put a negative in here. A negative to the 6th power is going to stay positive. Positive times a positive is still positive. Negative to the 5th power is going to go negative. Negative times negative is a positive. That's no sign change. But negative to the 4th power is positive times negative is a negative. There's one sign change. Negative cubed is a negative times a positive is a negative. No sign change. Negative squared is a positive. Positive times a positive is a positive. There's a second sign change. Negative to the 1st power is a negative times negative is a positive. No change, and then a plus 12. So there's, for negatives, you have 2 or 0. Okay? Solve the polynomial equation. Here it is. It's equal to 0. If you can factor it, you'll find quickly it won't factor because the x squared is 6x plus 1. You only take out a negative 1 here, giving you 5x plus 2. These aren't the same, so you can't factor. So I take the rational root theorem, plus or minus 1, plus or minus 2 over these guys here. Before I get into my fractions, I'll just try 1 and negative 1, 2 and negative 2. Hopefully we find a 0 by then. So you can use synthetic division or just plug it in. Either way, doesn't work, doesn't matter for me. 1 plus 6 is 7. Negative 5 plus 7 is 2. Hey, we found one right off the bat, 1. So that means that 0 is 1, which also is a solution, which then also came from the factor of x minus 1. Now I'm going to use and try to factor that big bad boy. So we have 6x squared. We have 2, multiply them together. That gives us 12x squared. Factors of 12x squared, that add to 7. Is it 1 and 12, 2 and 6, 3 and 4? There it is. 3x and 4x. GCF left. 3x here. 2, that box is positive, plus. GCF here. 2x. GCF here, 1. So there it is. 3x plus 2. And 2x plus 1. Which then, setting this equal to 0, I get a 0 of negative 2/3. Setting this equal to 0 and solving, I get a 0 of negative 1/2. And there's your solutions right there. Okay? Factor a polynomial into linear or irreducible quadratic factors. So again, try to factor it. Doesn't work on this one either, dang it. Who knows, you might get lucky one of those times. So we're looking at plus or minus 1, plus or minus 2, all over plus or minus 1. Try 1. If I just plug in 1, I get 1 minus 3 plus 4 minus 2. 1 minus 3 is negative 2 plus 4 is 2. Minus 2 equals 0, so 1 works. 1 is a 0, which means it came from the factor of x minus 1. Now I use synthetic division with 1. And that is a 0 right there, which is a good sign. I get x squared minus 2x plus 1 plus 2. There are no factors of 2 that add to negative 2. So I go to the quadratic, to an irreducible quadratic factor. So right there, you'd be done. Because they don't want you to go any further. Okay? If they did, just put in a quadratic formula. Away you go. More of same of the same-o. So you might want to practice. Maybe I'll put the answers up later, okay? Let's go ahead and skip down here to number 10. It's still same of the more. And let's look at some of these rationals really quick. So it says find all asymptotes, and we'll go ahead and graph. So remember, graphing is as easy as 1, 2, 3. First, find your zeros. So I take the top, x cubed minus 2x squared minus 3x, that equal to 0. Factor out an x. So I get x times x squared minus 2x minus 3. Hippo butt, x squared is what? Times what factors negative 3 to add to negative 2? Negative 3, positive 2. Don't forget this x up here. So my zeros are x equals 0. X minus 3 equals 0, so x equals 3. X plus 2 equals 0, so x equals negative 2. Those are my zeros. Vertical asymptotes. I have x squared minus 4 equals 0, which is x plus 2, x minus 2. So I get x equals negative 2. It's a vertical asymptote, and I get x equals 2. It's a vertical asymptote. But wait a minute. Oh dear. I have a 0 and a vertical asymptote are the same. That means they're no longer a vertical asymptote or a 0. They are a whole. There's a whole at negative 2. I rewrite this in factored form up top. X times x minus 3 times x plus 2. Over. Factored form on bottom. X plus 2, x minus 2. We're gonna let 2 get really close. We're gonna let x get really close to negative 2. So this number and this number will become exactly the same, so they'll simplify to 1. Something really close to negative 2 times something really close to negative 2 minus 3. Well, something close to negative 2 minus 3 is going to be really close to negative 5 times something really close to negative 2 is going to be really close to 10. So I get 10 on the top. Something really close to negative 2 minus 2 is going to get really close to negative 4. So that's negative 5 halves. So there's your whole. Negative 2 and negative 5 halves. Your vertical asymptote is at 2. It's not a whole. It's not a negative 2 is not a vertical asymptote because it's a whole. Be careful. They're going to try to trick you on that. Okay? And here they just give it to you in standard form or factored form. Let's do 1, 2, 3 again. 1, find your zeros. Find the zeros. I take x minus 2 times x plus 7 is equal to 0, so x equals 2. And x equals negative 7. Here I take for my vertical asymptote the denominator, x minus 3, set equal to 0. I get x equals 3. Number 3, and behavior. What matters most on top is x squared. What matters most on bottom is x. This is a slant asymptote. To figure out what that slant is, I need to divide these. I can synthetically divide. So I take 3. So remember, you take the 0 of this. Synthetically divide 1, 5, negative 14. 1 times 3 is 3, 8. 8 times 3 is 24. Add this up. 10, we don't care about the remainder. That is your slant asymptote, x plus 8. Hopefully that makes sense. Here we go. Oh, yep, and we got the MBI. Okay, we're good. So here's zeros. Take your numerator set equal to 0. So I get negative 1 and positive 3/2. Step 2, vertical asymptotes. I get 0 and 3. Notice none of these are the same, so they are vertical asymptotes and not zeros. And behavior. What matters most on top is 2x times x, which is 2x squared. What matters most on bottom is x times x, which is x squared. Those will simplify, leading us to 2. So y equals 2 is the horizontal asymptote. And you're done. I think I forgot to do horizontal asymptote up here. Apologize. It would have been x cubed over x squared, which is x. This is heading to a slant asymptote again. You need to do division. Now this one up here, you have to long divide to get it what it is. So long division, x squared minus 4 divides into x cubed minus 2x squared minus 3x. I want x squared to become x cubed and multiply by x. That's going to be x cubed minus 4x. Draw the line, change the sign. These cancel, gives us negative 2x squared plus 4x minus, 3x. 4x minus 3x, that's just 1x. So it gives us a negative 2x squared minus x, so probably plus x. How do I get x squared to become negative 2x squared minus 2? That would be plus 8. So these cancel. I get x minus 8 as my remainder. And I'm done. Okay. Let's graph this last one down here, and I think I'll probably call that a day if I can. I don't know if I'll get back to the other ones. We'll see. So, first of all, graphing this easy as 1, 2, 3. Find your zeros. To find the zeros, we take the top, x plus 2, set it equal to 0. X equals negative 2. So on my graph, I come to negative 2, put a dot. Step 2, find your vertical asymptotes. Factor that big bad boy in the denominator. It's going to get x minus 1, x minus 3. So x equals 1 and x equals 3. My vertical asymptotes. Third, end behavior. End behavior says what matters most on top, which is x, over what matters most on bottom, x squared. That's going to lead us to 1 over x. As then I let x get infinitely large. It's going to go to 1 over infinity, which is just going to 0. That means here's my horizontal. Don't worry about it. It can hit it. Horizontals are fine. Thing you don't know is if you're coming from above or below here and hitting that and then going back down. So put in negative 3 and see what you get out. So I get negative 3 plus 2, which is negative 1. Negative 3 squared, which is 9. Plus 12 is 21. Plus 3 is 24. So at negative 3, I'm negative right here. So this thing's got to be right around here, hit, come, and then it's going to keep going up. You can plug in 0, and you get 2/3. So yeah, you know it's coming up. Over here, see if you're above. So go to 4, plug it in. 4 plus 2 is 6. 4 squared is 16. Minus 16 is 0. Plus 3 is 3. 4, I'm at okay. That's above. Now, in between here, it's either got to go like this or it's got to go like this. Plug in 2 and see what happens. 2 plus 2 is 4. 2 squared is 4. Minus 8 is negative 4. Plus 3 is negative 1. So 2, I'm at negative 4. Okay, so this thing's got to turn. It's going to go like this. because it never crossed the x-axis here. Dang it, sorry. There it is. So at -3, we are -1/24. There's a 0. So it's coming along, hits, goes up. Over here at 4, when I plugged in a 4, we got 6/3, which is 2, so it had to go up. Then when I plugged in 2, I get -4 out here, so it's going to have to turn down because it doesn't cross the x-axis here. Okay, hopefully that helped, guys. Good luck. Remember, study hard, and we'll see you later. Bye. Hey, push that door open if you would. Go ahead and push her open.
So rude. I was looking at you.